Paradigms function to unify the thinking of a group of scientists, defining for them what is real and what is not. The paradigm tells scientists what kind of questions they should put to nature and what sort of answers they should expect in return. Paradigms can be useful in the conduct of science because they bring scientists the world over into a single shared framework of ideas and beliefs through which they can interpret reality. This has the advantage of focusing research along certain clear lines, but it also has the tendency to suppress dissent. Those who work within the paradigm are, to a large extent, operating in a bubble where they rarely meet with non-paradigm approved ideas. Because paradigms define reality in their own image, whatever contradicts the paradigm or cannot be assimilated or absorbed by the paradigm is necessarily left out and deemed by definition to be unreal and therefore unworthy of research. The overarching paradigm governing all branches of modern science is materialism, and it can be defined as the belief that matter and the four material forces, gravity, electromagnetism, and the strong and weak nuclear forces, and perhaps now also dark matter and dark energy, form the basis of reality, and that everything, including consciousness, can be fully explained in those terms. But consciousness has always been something of a problem for materialists, because even though the paradigm states that consciousness arises from matter, no one has ever been able to explain how that might occur. The paradigm itself is silent on this subject, offering no explanation and providing no way forward. Because of this inability to explain consciousness, materialists have attempted instead to explain it away, so to speak, by asserting that it is no more than an epiphenomenon of matter. As such, consciousness would no longer need a rigorous explanation in terms of mathematical equations and physical theory, because it would be something more akin to an illusion than to a real physical phenomenon. It could be safely left out of the physicists' equations altogether. As an epiphenomenon of matter, consciousness was deemed to arise from matter, but to be trapped within its own bubble, so to speak, unable to interact in any way with matter or anything else in the universe, including other consciousness. It is important to understand that in the materialist view, consciousness actually is matter ultimately, because it is entirely reducible to and identical with the specific matter from which it arises, the brain and nervous system, and lacks any independent existence of its own. This was, to say the least, a radical view and an extraordinary claim, but it had the great advantage of giving the 5 axioms the internal consistency they needed, while at the same time dispensing with the thorny problem of consciousness altogether. And as an added bonus, it closed the door once and for all on the church, with its troublesome realm of mind or spirit. It was a masterstroke. Consciousness was to be seen as only pseudo-real, and when the brain died, consciousness died with it. The materialist paradigm, having gained ascendancy over the hard sciences, like physics and chemistry, soon began to infiltrate the soft sciences as well. Materialism eventually worked its way into every field, from biology to philosophy, and today is such a pervasive belief system that its influence has spilled out of science and academia to influence the culture at large. And yet, strangely, given its importance, materialism is rarely taught explicitly in schools and universities, even within science departments. Because of this curious omission, the underlying belief system of materialism operates largely out of sight, evading conscious scrutiny but always quietly influencing our behavior and thought. The paradigm is unconsciously absorbed by almost everyone in the West as part of the cultural inheritance, coloring our worldview and subtly determining what sorts of ideas we consider plausible or acceptable and which we do not. The more an idea conflicts with the paradigm of materialism, the less seriously it is entertained by mainstream science, and the less funding it will attract in research settings. The more an idea threatens the paradigm with counterfactual evidence, the more it is scorned. The most threatening ideas of all, like telepathy or clairvoyance, which are also supported by the strongest counterfactual evidence, are effectively considered taboo subjects for scientists and academics. Even voicing an interest in such ideas is off limits and can be career-ending. It is no wonder then that these topics receive little or no funding for research, or that few papers are accepted for publication, or that scientists do not even feel free to discuss such ideas openly among themselves for fear of ridicule or worse, ostracism. But though materialism has enjoyed a long and successful run on the stage of world opinion, its remaining time in the limelight may be growing short. In The Structure of Scientific Revolutions, Thomas Kuhn argues that science undergoes periodic revolutions when one paradigm is overthrown and replaced by another. Such revolutions involve a gestalt-like, all-or-nothing shift in the way that reality is construed. In between scientific revolutions, there is a stable period that may last for decades or even centuries, during which scientists put paradigm-approved questions to nature and seek answers through experiment. Kuhn refers to these periods as normal science, because the paradigm is more or less accepted by all working scientists who frame their questions within the bounds of the paradigm and expect their answers to fit in return. As long as there are questions still to be asked within the approved paradigm and details to be worked out, scientists have their work cut out for them, and they have no incentive to look for new paradigms. Kuhn refers to this kind of work as a mopping up operation. Few people, writes Kuhn, who are not actually practitioners of a mature science, realize how much mop-up work a paradigm leaves to be done. Mopping up operations are what engage most scientists throughout their careers. They constitute what I am here calling normal science. Kuhn goes on to make an important point, one that exposes the downside of paradigms, and not just for science, but for society as a whole. For paradigms serve to constrain the imagination by defining what sorts of things are possible and what sorts are not possible, and what entities can and cannot exist. Like other people, scientists are social creatures who seek approval from their peers and fear their censure. As Kuhn notes, a paradigm acts to limit thought and constrain action to within certain carefully circumscribed areas. Closely examined, writes Kuhn, whether historically or in the contemporary laboratory, that enterprise normal science seems an attempt to force nature into the preformed and relatively inflexible box that the paradigm supplies. No part of the aim of normal science is to call forth new sorts of phenomena. Indeed, those that will not fit the box are often not seen at all. Scientists do not treat anomalies as counter-instances, though in the vocabulary of philosophy of science that is what they are. This is an important point. If scientists do not treat anomalies as counter-instances, then when a result appears that contradicts the dominant paradigm, evidence for telepathy, say, it is often not seen at all and silently swept under the rug. If a result is too blatant for that treatment to work, scientists can still evade the problem by claiming that given enough time, the paradigm itself will be able to explain it. This maneuver allows a scientist to indefinitely postpone dealing with a troubling counter-instance by putting it off into the distant future. Biologist Rupert Sheldrake has dubbed this approach the promissory note defense. Give us another 100 years and we'll explain everything. During the conduct of normal science, then, anomalies will generally be ignored for as long as possible. It is only when they become so prevalent that they can't be ignored that they turn into a problem, eventually threatening the paradigm itself. Anomalies, observed social anthropologist Charles Whitehead, tend to get swept under the carpet until there are so many of them that the furniture starts to fall over. When we pull back the carpet and look at what anomalies have gathered there, it becomes apparent that they have one thing in common. They support the idea that consciousness exists independently of matter, just as the pioneering quantum physicists suspected. Compounding this problem is the fact that scientists practicing normal science do not generally try to invent new theories in an effort to accommodate anomalous evidence. That is not part of the mopping up work. The younger generation of scientists who are typically more open to new theories, may find themselves pressured by more senior scientists to uphold a paradigm to which they, the older scientists, have devoted much of their careers. This helps to explain why scientists, as Kuhn tells us, are often intolerant of new theories invented by others. Instead, normal scientific research is directed to the articulation of those phenomena and theories that the paradigm already supplies. Perhaps, Kuhn concludes, these are defects. They are defects indeed, and are what led Max Planck to quip that science progresses one funeral at a time. He was only half joking. If the point of science is to seek a true understanding of reality, and not just to uphold a given paradigm, then scientists should be alert to counterfactual evidence and be ready to test alternative paradigms that better fit the evidence. But the culture of science is very conservative, and scientists, being human, are as reluctant as anyone else to part with cherished beliefs, even when better alternatives are known to exist. This reluctance can be seen in action in the behavior of 16th century astronomers who bitterly resisted the radical new ideas that were being put forth by a young upstart astronomer named Copernicus. Prior to Copernicus, the European perception of planetary motion was geocentric. This was the old Ptolemaic paradigm, with the Earth at the center of the universe and the Sun and planets circling around it. It seemed quite reasonable at the time, and even enjoyed the approval of the Church. One thing the Ptolemaic picture had in its favor was that the Earth obviously did not appear to move, but the Sun and planets did. And a second was that Ptolemy was able to predict celestial motions that were confirmed later by observations. The trouble, when it arrived, was in the details of those planetary motions, which contained some puzzling anomalies. Copernicus had long been concerned with the problem of the planets. When Mercury, Venus, Mars, Jupiter, and Saturn are at their brightest, that is, closest to Earth, their motion stops, and they reverse course for a time before stopping again and resuming their usual forward motion. The Ptolemaic model could not account for these strange retrograde movements, yet astronomers soon found that they could describe them and even predict them, but they could do so only by adding extra bits and pieces to the original theory. These extra bits and pieces, called deferents, epicycles, ecliptics, and equants, were invented for one purpose only: to account for the anomalies of motion otherwise unaccounted for by the geocentric paradigm. Explanations of this sort are called ad hoc explanations, from the Latin phrase meaning for this, as in for this purpose only. Ad hoc explanations do not arise naturally from a theory and must be applied from without, stuck on by brute force, as it were. They are not very elegant and are considered poor form in science because they indicate that there is probably something wrong with the underlying paradigm. In this case, of course, there was.